All right, so we're not really in a section of chapter 4. We're kind of in between two sections. So I'm just going to call it algebra review. And what we're doing is we're solving systems of equations. And we've done quite a few of these when we did our algebra review worksheets. So what we're going to do today is we're going to solve systems of equations because the reason we're doing it today is it comes up in the homework in some different places. So what we're going to do is solve our systems of equations by substitution. We could also, it's also possible, and you probably did a little bit of it in Algebra 1, you'll do a little bit more in Algebra 2. You can also solve by graphing. And elimination. And what we're doing here is we're looking at equations of lines. We have two equations of lines, y equals something, y equals something else. So we're looking for the point where the lines cross each other, where they intersect. So you could graph the two lines and figure out the point where they intersect. If you do the graph by hand, you get pretty close. We could also solve by elimination, and that's where we add or subtract the two equations to get rid of either the x or the y. But what we're looking for is the point where the two lines intersect. So we always end up with an x and a y for our answer. We end up with a point. All right, so all I want to do is go through a couple of examples of solving these equations by substitution, and talk about how we go about that. So let's say we have this equation: 2x minus 2y equals 8, and 9x minus 3y equals negative 6. And we want to figure out x and y that works in each of these equations. So my first step when we solve by substitution is we solve one equation for x or y. And I usually look at the equations and think which one is going to be the easiest to work with, which one looks like it's the least work. So for this first one, I'm going to use the first equation because I can see that I can divide everything by 2 and it works out nicely. This one will work out okay, but I think I like dividing by 2 better than dividing by 2. So here's our first step. So I'm going to solve this one for x. So I have 2x minus 2y equals 8. If I just pick that first equation, it looked easiest to me. Solve it for x. So I'm going to add 2y. So I get 2x equals 8 plus 2y. And then I can divide everything by 2. And when I divide by 2, make sure you divide everything by 2. I'm going to divide everything by 2. So I get x equals 4 plus y. My second step is I'm going to substitute into the other equation. That's why we call it substitution. and I substitute into the other equation because I'm going to substitute this back into the first equation. I just get back to where I started. All right, so here let's do step 2 now. So here's step 2. And when I say substitute, what I'm going to do is take this, and it says x equals. So I'm going to take this and substitute it right there for x. I'm substituting that into the other equation. So 9 times 4 plus y minus 3y equals negative 6. And then now I only have a y in this equation, and I can solve for y. So my third step is solve for the variable. So there's my substitution. Now I'm going to do my third step. So to solve for the variable here, what do we have to do first? We have to multiply. So order of operations tells us to do parentheses first. So I'm going to do the parentheses. I'm going to distribute them. So 9 times 4 is 36 plus 9y minus 3y equals negative 6. This looks pretty easy. So I get 36. I'm going to combine like terms here. 9y minus 3y is 6y equals negative 6. Subtract 36 from both sides to get the y part by itself. So I get 6y equals negative 6 minus 36 is 42. Now I can divide by 6, and y equals negative 7. So now I know y, and the last step finally is plug into one equation to get the other variable. And the easy one to plug into, I'm going to take this y equals negative 7, and we already solved this here. X equals 4 plus y. So here's my step 4. X equals 4 plus negative 7. So x equals negative 3. And my answer is a point, negative 3, negative 7. So if we graph those two lines, they would cross at the point negative 3, negative 7. So I get an x and a y. Solve one equation, substitute into the other equation, solve for one variable, plug that into the one of the two equations to get the other variable. Now we've done several examples of these first semester. All right, questions there? Okay. A lot of the problems in your book are nice because they're written like this. Y equals 3x plus 2, and y equals minus 8x plus 5. So step 1 in our steps for solving systems of equations says solve one of the two equations for x or y. Do we have to do that? Oh, it's already done, right? So what would be our next step here? How would we, I'm not going to go all the way through this one, but I want to show you when we set this up, what would be our next step? How would we do this? What does step 2 tell us to do? Step 2 tells us to substitute into the other equation, right? Well, this says y equals 3x plus 2. I'm going to take that and plug it in right there. So I get 3x plus 2 equals negative 8x plus 5. And then we solve this equation for x. Once we have x, we can plug x into one of these two equations to get y. So when you have your equation set up this way, where it says y equals something and y equals something else, you can just set the two equations equal to each other because they both equal y. What's that? Then we solve x. We want to get all the x's together on one side. So what would be our first step if we were solving for x here? What would we want to do? Do what? Add 8x, get all the x's together. So we can go through this. 3x plus 8x is 11x plus 2 equals 5. This turns out we end up with fractions here. So then we subtract 2. 11x equals negative, 5 minus 2 is 3. Divide by 11, and x equals 3 over 11. And then to find y, we would plug that into one of the equations. Y equals 3 times 3 over 11 plus 2. And we could do this with fractions, or we could turn 3 over 11 into a decimal and do this as a decimal. Calculate that out. But in the book, a lot of the problems are set up this way, where you don't have to do that first step. You just, the equation's already solved for one of the variables. You can just set them equal to each other. All right. I want to do one more example and then talk about what a couple of different possibilities for lines. All right. What if we had 2x plus y equals 5 and 4x plus 2y equals 8? And we want to solve this system of equations. So which equation is going to be the easiest to solve for one of the variables?
Lower.
The lower one? I like this first one. It already has y, right? So let's work with that first one. 2x plus y equals 5. So how do we get y by itself here? Subtract 2x. Just get that away from that side of the equation. So subtract 2x. I get y equals 5 minus 2x. And then we substitute that into the other equation. So I'm going to take this and substitute it into the other equation right there. So I get 4x plus 2 times 5 minus 2x equals 8. And my next step here, I deal with these parentheses. So I get 4x plus 10 minus 4x equals 8. And when I simplify this side, what do I get? 4x minus 4x is 0x. 10 equals 8. What does that tell us? No solution. Because when is 10 equal to 8? Never. So what does this tell us about these two lines? They don't intersect. They don't intersect, so they are parallel. These lines are parallel. You could also solve a system of equations, and there's one other possibility. Sometimes you'll solve a system of equations and you get something like 4 equals 4. What does that tell us? you have an infinite number of solutions. They are the same line. So if you simplify it, instead of two lines, you have them right on top of each other. It's the same line. So this, we say, is an infinite number of solutions. Because when is 4 equals 4? Always. Infinite number of points. And this happens when we have the two equations are for the same line. So when you come up with an answer, 4 equals 4, 0 equals 0, 1 equals 1, something like that, that means you have an infinite number of solutions. Now, one place to be careful, it doesn't mean the solution is infinity. It means that an infinite number of x's and y's satisfy that work in those equations. It doesn't mean that every x and y have to happen in pairs, but you have an infinite number of them. And if you have 10 equals 8, 1 equals 2, 5 equals 0, something that's impossible, you have no solutions. And that tells you the lines are parallel. So our lines can cross at a point. They can be parallel, have no solution, or you can have an infinite number of solutions. Same line. All right, questions there? Okay. Our homework, page 2, where are we? Page 9, no, that's it. 257. Number 1 through 8. And also on page 257, they work a couple other examples of solving these systems of equations. So you can look at a couple of examples in the book also.